will cancel out to 1. And that will make this x is equal to log base b y. That's one way of doing it. You can also use a change of base formula to figure it out, but this is one way of doing it. So this is how you convert from an exponential expression to a log expression. Let's see if we want to go the other way. Let's see if we want to go from a log expression to a exponential expression. So if I have y equals log base bx, and this is, I'm going to do more examples with numbers, so it's a little bit more clear. But just so you can, in general terms, understand. Remember, your base value is always b. So I'm going to raise both sides into the exponential form, or sorry, into the exponential plane, I guess you could say, and do this. B to the power of y is equal to b to the power of log base bx. You can do this. And if I were to do this, what would happen? Well, you know how division and multiplication are kind of like opposites of one another? So if I were to do, let's say 100 times 3 and then divided by 3, that'll just be 100. It doesn't change because you times it by 3, but then you did the opposite, which is dividing by 3. So just like that, if I were to take the exponents and log of the same thing at the same time, it would kind of cancel out. So b to the exponent log base b, and remember the bases have to be the same. This is the key. You can only do this cancellation if the base values are the same. That's what we purposely chose what value to raise everything by. So we have b to the power of y is equal to now x, because that's all that's left on the side. A little confusing, I know, but that's that. Let's now do some examples here. Let's see, we have 16 equals 2 to the power of 4. And the question is asking us to, I should probably copy that too, actually. Question is asking to write it in terms of the log form. So take the log of both sides. And remember, we want to take the log of base value 2. Why 2? Because that's my base value. We're trying to keep the base value the same. So in exponential form, what's my base number? It's 2. It's 2 that's being raised to the power of 4, right? So my base value is 2. So I'm going to take log base 2 on both sides. I'm going to bring the 4 here. Remember, exponents can just be written in front of logs. And remember, whenever you have log 2 of 2, well, that's just 1. So that's 4 times 1 and just cancels out. So log base 2 of 16 is equal to 4. That's how you rewrite it in terms of log. Example B, same thing, take the log of both sides. Now what's my base value here? Well, what has the exponent? N has the exponent. So I'm going to take log base n to both sides. And remember, the exponent just comes in front. So this is log base n, 3 log base n. And we know that log base of a number, that's that same number as just 1, cancels out. So here we have log of n, base n, sorry, m is equal to 3. And that is how you rewrite it in terms of a log expression or log form. Here, what's the exponent? The exponent is -2. So if we want to rewrite this, what I would do is base value of 2. No, hold on. Can we do negatives? Can we do logs negatives. Yes, we can. Remember, what's my base value? Log base 3. I'm going to copy this and move it over. Okay, let's move it here. So, log base 3 of 3 to the power of negative 2 is equal to log base 3 of 1 over 9. Why is it log base 3? Because 3 has a term with the exponent. So the base value is 3, and we want to keep the base values the same. The exponent goes in front, so negative 2 times log base 3 of 3 is equal to log base 3 of 1 over 9. And log base 3 of 3 is just 1. So this becomes negative 2 is equal to log of base 3, 1 over 9. And that's the answer. That's how you rewrite it in terms of log form. Yeah. Yeah. All right. Now we're going to go the other way. Oops. And rewrite terms from log expressions or log equations into exponential forms. What's the base value? Once again, base value is 4 here. So I'm going to raise the whole thing to 4 to the power of log base 4, 64 is equal to 4 to the power of 3. And this will cancel out. So we're left with 64 is equal to 4 to the power of 3. When it comes to y equals log x, same thing. What's my base value for log here? If you forgot, the only time you don't write the number there, it's when the number is 10. So the base value is 10. So I'm going to take 10 to the power of y is equal to 10 to the power of log x. And we know that this is technically base 10. This will cancel out. And that's equal to x. So 10 to the power of y is equal to x. Basic stuff. Basic stuff. Okay, time. Oh yeah, this is good stuff too. So there's a few ways to solve, actually evaluate, meaning solve, the problem. When it comes to logs, you can use a calculator, or you can use some, some sense of exponents and whatnot. So here we have log base 3 of 81. What does that mean? It's a good question. Basically, they're looking for... Okay, let's rewrite this. Yeah, let's rewrite this. Let's rewrite this in exponential form. So remember, your base value is 3, right? So this is going to be 3 to the power of y is equal to 3 to the power of log base 3, 81. And we know that 3 to the power of log base 3, that just cancels out. So 3 to the power of y is equal to 81. And since I know my base value is 3, I can kind of do this, where I have 3 to the power of y is equal to 3 to the power of something, which is equal to 81. So you have to realize that 81 can be rewritten as 3 to the power of 3 times 3 is 9 times 3 is 27 times 4. Okay, 3 to the power of 4. If you don't believe me, you can do this like 3 times 3 times 3 times 3, and you should get 81. And in this case, when we have both the base values being exactly identical, we know the exponents have to be the same, so y is equal to 4. That's one way of doing it. Let's see how did it. Yeah, I did it the same way. All right. And And what are they doing here? Let's see. Same question? Okay. Okay, yeah, that's all right. So what I'm going to do here is I'm going to write, well, my base value is 4. Log base 4. I'm going to rewrite 64 in terms of 4 to the power of something. Now, this may not always be possible, but if it is, then you can make your life easier. And I know that 4 to the power of, is it 3? 4 times 4 is 16. Yeah, 3 is equal to 64. So I'm rewriting 64 as 4 to the power of 3, 4 cubed. And since now that we have an exponent, that exponent can come in front of the log. So this is just y equals 3 times log 4 to the, log base 4. And this just becomes 1. So y is equal to 3. That's the answer. Now there are ways to just use your calculator. You don't really need to do these conversions of exponents and stuff. You can always use your calculator to figure this out. You just have to use the change of base formula, because there is no log base 4 in your calculator. So if you want to do this in your calculator, how would you do it? Good question. So remember, log change of base formula is log bm is equal to log of m over log of b. So b being the base, so this is 4. So that's going to be log of 4, and m being this value here, 64, log of 64. So if you were to plug this in your calculator right now, log of 64 divided by log of 4, you should get 3. That's how you can solve it using your calculator if you didn't want to convert stuff. Okay. And now, yeah, just a little bit more examples. Let's see. Log base of 1 over 100. We know log is generally a base 10 if there's nothing written. And we can rewrite this as 10 to the power of negative 2. How do I know it's 10 to the power of negative 2? Well, I know that 10 times 10 is 100. Okay, so log base 10, brackets 10 to the power of negative 2. And negative 2 comes in front. Oh, sorry, what am I doing? Then it's just log base 10 of 10. That's just 1, so that's equal to negative 2. Here we have same thing, log base 2. This is the same thing as 2 to the power of, well, 2 times 2 times 2 is 8, right? So that's 3. But since it's in the denominator, it's 2 to the power of negative 3. And hopefully you can see that that's just going to be negative 3. So yeah, that's how you do that example.